Watch closely. Two teams pass a basketball back and forth. One team in white, one in black. Your only job is to count the passes made by the players in white. Simple enough. Except somewhere in the middle of that video, a person in a full gorilla costume walks directly through the middle of the court, stops, faces the camera, thumps its chest, and walks off. About half the people watching never see it at all. This is the invisible gorilla experiment, and for 25 years, it's been used as proof of a simple, unsettling idea. You are blind to more of your own world than you think. But there's a twist buried in the research that almost never makes it into the popular version of the story. The experiment was built in 1999 at Harvard by two psychologists, Daniel Simons and Christopher Chabris. Their setup was almost embarrassingly simple. 6 people, 3 in white shirts, 3 in black, pass basketballs around in a tight, chaotic scrum. Viewers are told to silently count how many passes the white team makes. 9 seconds in, a person in a full gorilla suit strolls into frame right through the middle of the players, stops center screen, beats its chest twice, and walks off. It's on screen for about 5 seconds. It isn't hiding. It isn't subtle. And still, roughly half the people watching the video for the first time report seeing nothing unusual at all. When Simons later asked people beforehand whether they thought they'd notice something like a gorilla walking through a basketball game, about 90% said obviously yes. Of course they'd see it. It's a gorilla. That gap between how observant we assume we are and how observant we actually are is what made the experiment famous. Simons and Chabris eventually turned it into a best-selling book, and the phenomenon got a name: inattentional blindness. When your attention is fully consumed by one task, your brain can fail to register something else entirely, even something walking directly through your field of vision. The story spread everywhere. It got cited in courtrooms to question eyewitness testimony. It got used to explain why drivers on their phones miss motorcycles, why radiologists sometimes miss tumors, why we walk past people we know without saying hello. The lesson seemed airtight. Your eyes see everything, but your mind only lets in what it's paying attention to. Everything else might as well not exist, except that framing has a hole in it, one that took over 2 decades and a study spanning roughly 25,000 participants to properly expose. In 2024, researchers led by Michaela Nartker at Johns Hopkins revisited the gorilla paradigm. But this time, they didn't just ask a simple yes or no question. They asked people who claimed not to have seen the gorilla to make a series of forced guesses about it anyway. What color was it? Which direction did it walk? Did it stop in the middle of the screen? And here's the part almost nobody talks about. Even the people who insisted they saw nothing were guessing correctly at rates far higher than chance. Their eyes had registered the gorilla. Some part of their visual system had processed it, tracked its color, tracked its movement. What failed wasn't perception. What failed was the ability to consciously report it, to turn that information into something they could describe afterward. That distinction matters more than it sounds. For 25 years, the takeaway from this experiment was that unattended information simply doesn't get seen, that it vanishes the moment your focus is elsewhere. The newer research suggests something stranger and, in some ways, more disturbing. The information gets in, your brain absorbs it, but without conscious attention locking onto it, you have no access to that information, no ability to pull it back out and act on it, even though some quiet part of you clearly registered it happened. There's a second detail that rarely gets mentioned either. Researchers at the University of Utah ran their own version of the study and found the odds of noticing the gorilla weren't fixed at 50-50 for everyone. They depended heavily on something called working memory, essentially how much mental bandwidth a person has free at any given moment. People with high working memory capacity noticed the gorilla about 2/3 of the time. People with lower working memory capacity noticed it only about a third of the time. The counting task wasn't just competing for your attention, it was competing for a limited resource, and how much of that resource you had left over determined whether the gorilla ever broke through. So the real finding isn't simply that we're blind to the world around us. It's that awareness is a resource, one that gets rationed depending on what you're already carrying, and that even the things you miss might still be quietly logged somewhere your conscious mind can't reach. Think about what that means outside the lab. The driver who didn't see the pedestrian wasn't necessarily failing to look. The radiologist who missed the mass on the scan wasn't necessarily careless. Their brains may have registered exactly what was there. It just never crossed the threshold into something they could name, describe, or act on in time. We like origin stories where the mind either sees something or it doesn't, where attention is a spotlight and everything outside the beam simply goes dark. The truth looks messier than that. Somewhere between total blindness and full awareness is a strange middle ground where your brain knows more than you do and has no way of telling you. So the next time you're certain you would have noticed the gorilla, remember that even the people who missed it weren't seeing nothing. They were seeing something they couldn't reach.